Hello everyone. In this video, we will find the focal length of the concave mirror by using UV and 1 by U, 1 by V graph. Here, we are finding the rough focal length of the concave mirror by focusing the image of trees at infinity at the wall just shown, and it is observed that the distance of the concave mirror from the wall is 10 centimeter as shown here. It is measured with the help of a scale, and it is clear that the image forming on the wall is real and inverted, and the distance of this image from the mirror is 10 centimeter, which is the rough focal length of this mirror. It is clearly visible here. Now, in order to proceed further, we have to set the mirror on the optical bench as shown. The mirror is there on the optical bench, and the object needle is placed here, and the removal of parallax is been done, and the image is forming exactly at above the object. The position of the mirror is 50 centimeter, and the position of the object and the image formed above it is same, which is 30 centimeter as shown. Now, then
Object
for the
placed
second reading
between
between F and C and beyond C is been shown here. Both the object needle and the image needle is shown here, and image forming upside down, and parallax is been removed, and the position of the mirror is same 50 centimeter, and one needle at 26 centimeter and the other one is at 33 centimeter. Here two cases of the mirror been discussed. One object is between F and C, and object is beyond C. When this needle is behaving like an object, the other will be treating as an image needle, and vice versa. So one time object distance is 17 centimeter and the image distance is 24 centimeter, and for the another reading we can interchange the reading. Now on changing object distance, image distance will be changed and one more set of reading will be obtained, where the position of object and image needles are 33.5 centimeter and 25 centimeter. As a result, object and image distances are 25 centimeter and 16.5 centimeter. These readings can be interchanged, and all the readings are tabulated as shown here, where rough focal length is 10 centimeter, and all the readings been calculated, which are U and V. For the first case, image and the object both are at same distance. This is the case when the object is placed at C, image will also be formed at C. U and V both are 20 centimeter, and 1 by U, 1 by V calculated. Then for second set of reading, where U and V are calculated 17 and 24 centimeter, and again one more set of reading can be obtained just by interchanging the value of U and V as shown here. Both the needles will serve the purpose of image needle as well as object needle. Then for one more setting, another set of readings are obtained where U and V are 16.5 centimeter and 25 centimeter, and again these readings can also be interchanged to get one more reading, and 1 by U and 1 by V is calculated in every set of reading as shown here. Here, if one needle is treating as object needle, the other one will be image needle. So In one adjustment, we can get two readings, and hence five readings of U and V are obtained. And now let's draw the graph between U and V. First, mark 20 against 20. This graph will be in the third quadrant as both U and V are negative. Then for the second reading, U and V are marked as shown, which are 17 and 24. And for one more reading, U and V are interchanged as shown, and again it is marked here. Then for fourth and fifth reading, 16.5 and 26 are marked. And here scales should be chosen in such a manner so that the readings can be easily marked, and on both x and y axis the scale should be same. It is an important point to be noted. Now, in order to calculate the focal length, we will draw a square by drawing an angle at 45 degree as shown here, and focal length can be calculated from the points A and B. Point A is giving the point where U and V are same, so this is a condition of double focal length. So just by dividing OA and OB distance by 2, we will get the focal length from the UV graph. Now, in order to find the focal length from the 1 by U 1 by V graph, we will draw the graph as shown here. In this graph also, the scale taken will be same, and at the point where this graph is touching U axis and V axis, the 1 by F will be equals to 1 by U and 1 by F equals to 1 by V. So the focal length will be 1 upon distance OP or distance OQ. First, all the readings are being plotted in the graph, and we will obtain the straight line as shown. And then with the help of point P and Q, we can calculate the focal length as shown here. The focal length is coming out to be again 10 centimeter from this graph as well. Point P is the point where focal length is 1 upon 1 by U. So 1 by U is OP distance, which is 0.10, and the reciprocal of it will give the focal length 10 centimeter from both the points P and Q. Thank you.